What's up guys, Lee here, and in this video lecture we will be learning about how to classify and calculate the energy and power of a discrete time signal. Alright, let's start off with the energy signal. I've listed 3 important details that you need to know to be successful with these types of signals. Number 1, energy signals are always aperiodic. Number 2, energy signals have 0 average power. And number 3, to calculate the energy of a signal, use the formula E of x equals the summation from negative infinity to positive infinity, absolute value of x of k squared. Moving on to the power signal, we have 4 rules here. Number 1, power signals are always periodic. Number 2, power signals have an infinite total energy. And number 3, to calculate the power of a signal, use the formula 1 over k naught, summation of k from 0 to k naught minus 1, absolute value of x of k squared. Number 4, we can use a shortcut. If we have this given form, we can say that p of x is equal to a squared over 2. I've also listed some helpful hints to help you simplify some of these signals. We have the product identity, which is going to be cosine of x times sine of y equals 1/2 sine of x plus y minus sine of x minus y. We also have the double angle formula, which is cosine squared of x equals 1/2 times 1 plus cosine of 2x. We also have the summation property for constants, which is the summation of I equals 1 to n times the constant equals n times that constant. All right, moving on, we'll go ahead and solve an example for you guys. x1 of k equals cosine pi k over 4 times sine of 3 pi k over 8. We go ahead and use the product identity formula to simplify this signal. Cosine of x times sine of y equals 1/2 sine of x plus y minus sine of x minus y. So applying this to the signal, we can go ahead and get 1/2 sine of 5 pi k over 8 minus sine of negative pi k over 8. Also know that sine of minus t equals minus sine of t, so we can go ahead and apply that, simplify it a little more, changing it to plus, and the argument is now positive. Go ahead and distribute the half. We get this right here. And then we know that, little fun fact, a dt sinusoidal sequence, x of k, with the form a sine omega naught k plus theta is periodic if omega naught over 2 is a rational number. So we'll use this to test each term of our signal. We'll start off with the first half, 1/2 sine of 5 pi k over 8. So we'll take the omega is equal to the 5 pi over 8. We'll use the definition here and get 5 pi over 8 divided by 2 pi, and that'll give us 5 over 16. So we can also do this with the second term, 1/2 sine of pi k over 8. Omega naught is equal to pi over 8, and we can say that pi over 8 over 2 pi is going to be 1 over 16. And that's going to be the period of each term. So now we can find the fundamental period. And that's just going to be equal to 16 because of these two denominators. So since 16 is a rational number, we can say that this is a periodic signal, and periodic signals are always power signals. So knowing that this is a power signal, we can go ahead and assume that the energy is infinite, and then we can go into calculating power. So knowing that this is a sinusoidal sequence, we can go ahead and use rule number 4 and make it easy by saying p of x is a squared over 2. So with this first term here, 1/2 sine of 5 pi k over 8 plus 1/2 sine of pi k over 8. The 8 is going to be 1/2, so we can say 1/2 squared over 2 plus 1/2 squared over 2. And that's going to be equal to 1/4. Alright, I hope you guys learned something, and thanks for watching.